Hello viewers, welcome back to another section of my tutorial. Still on exact differential equation. So I have another problem in exact differential equation, and this is inverse trig differential equation problems. So we have x tan inverse of y dx plus x squared over 2 multiplying 1 plus y squared dy equals 0. So as usual, you have to prove that this is an exact differential equation before you continue, but let's move straight to save time. This equation is an exact differential equation. So in order to solve, we have this place being the partial derivative with respect to x, that is the dx, and partial derivative with respect to y. So we can choose any of them, that is finding integral of mx dx, or using the integral of ny dy. So always you have to choose the parts which will make things simpler. All of them will arrive at the same answer, but you may suffer along the way if you don't choose the right part. So let's use the dy part. I can see if you integrate this, things will be simpler. So let's see. We are going to take the integral of ny dy to solve this problem. To do that, we take the function back here. We're going to have integral of x squared on 2 multiplying 1 plus y squared all dy. As we are integrating with respect to y, every x term become a constant. We move them out, so we get x squared on 2 integral of 1 over 1 plus y squared dy. And having this, you know that the integral of 1 plus y squared is the same as tan inverse of y. So this becomes x squared on 2 tan inverse of y. By inverse trig ratio, you have to know this offhand. So using this, plus h of x is equal to c. That would be the solution for the general solution for this exact differential equation. But we need to find a value for h of x to make our solution complete. So to do that, we will differentiate this with respect to x. Then after, we will equate it to the partial derivative with respect to x part here. So now how do we do that? So with respect to x, we can see that every y term becomes a constant. So let's see. When I differentiate this with respect to x, I'm going to get 2 multiply this, where it will cancel. So that will give me x tan inverse of y, because y part becomes a constant, plus h prime of x is equal to 0. Comparing this to this part, I can easily see that my h prime of x is 0, because there is nothing here. It's only this thing here, so which is also the same thing here. So I can see that my h prime of x is equal to 0 here. So therefore, I'm going to have my h of x also to be the integral of 0, which is a constant c. But as we are using or as we are solving differential equation, the constant is always a single constant and is placed at the right side. So we are going to get c here, but our final answer is going to be x tan inverse of y is equal to c. As simple as that. Thank you for watching my video. Kindly subscribe and also like, as I'll be posting subsequent tutorial videos.